often there are 2 degrees of freedom for this rigid body, okay. And if I have 2 constraints for this rigid body, that means total degrees of freedom is equal to 0, very simple. How many degrees of freedom do I have? I have 3 degrees of freedom for a rigid body. Since this is a beam, one of the displacements, the horizontal displacement is a redundant, which means I will take it to be 2 degrees of freedom, y displacement and rotation, okay. And how many constraints do I have? 2 constraints, which means that imposes 2 constraints to the degrees of freedom, which means I have a 0 degree of freedom system. 0 degree of freedom system means it is a stable system, okay. You will not see any movement of this rigid body. If I have to see the movement, I either have to remove it completely. If I remove it completely, how many degrees of freedom I have? There are no constraints, which means it has 2 degrees of freedom. Supposing I instead put a hinge over here, this means I have not 2 but 1 constraint, which means I will get 1 degree of freedom. Supposing I do like this, please notice it carefully. I am going to release the vertical displacement, but will not allow rotation, which means what? It is rigidly connected to this guy, and this guy can slide only like this. So this guy cannot rotate like this, okay. So another way of drawing this is connected through hinges, alright. Let us come back to this A later. Between AB and BC, what do I know? The displacement, supposing I fix AB, the displacement B of BC is fixed, alright. So it offers a constraint at B, whatever is the displacement of AB at B, it is the same displacement of B at BC, correct, and therefore can it rotate between them? The rotation between them is allowed, right. So as it is, we already know each one of them can have 2 degrees of freedom, so I am just writing that here, okay. This is free degrees of freedom. It does not make sense, but let us just understand it this way. If I completely free it as a beam, which means horizontal displacement is redundant, 2 degrees of freedom possible for AB, BC and CD. For AB and BC together, there is one constraint that is offered at B, right. So I have a -2 -1 between AB and BC. Between BC and CD, another constraint is in the form of hinges there, so one more is gone, alright. How about the support at F? It vertically constrains the motion. Support at G again vertically constrains the motion, which means one constraint each at F and G, right. So F offers -1, G offers -1, alright. So we have considered F, we have considered C, we have considered B, we have considered G, D is free. How about A? A I have arrested, like what we have done here, we have arrested both rotation and vertical displacement at A, which means A offers -2. So let us total them, -1, -1, -1, -1, -2, total is 6. I have 6 degrees of freedom, constraints are 6, which means I am not left with any degree of freedom, okay. So for the system, total degrees of freedom equals 0, which means it is a determinate what do I have? I have a support over here, I have another support over here, I am just drawing those supports. At A I am releasing the vertical displacement, yet rotation is not possible. Okay, this is at A. Okay. How many degrees of freedom does it have? DOF equals 1, which means if I specify one displacement, vertical displacement or rotation at any one of these points, I can find out the virtual displacement at any other point. Okay. The only condition is what I have to impose is a kinematically admissible law. This will remain horizontal. The reason is I am not allowing any rotation, it is only possible to move it this way. So I have moved it, and let us say this displacement is delta, okay, delta A, but uniquely specified, so I am just going to call it as delta. Okay. Okay. At this point what should happen? This will not allow movement, which means the only way possible is going along this. Okay. So the point C has to move down like this. Okay. Now at point C again this guy will not allow vertical movement, which means the only way possible is a displacement like this. Very simple. Okay, geometrically if I draw it, it will make it simple for me. Okay, the moment I know this, I have solved the problem. Okay. Now let me draw the active forces. Remember I have not drawn any active forces yet. Having released the vertical displacement here, I have to apply a vertical reaction. Let us say this is A y. Okay. Again it's an option, I have used vertical this way. So let us just have a notion of what would be the reference. The reference is the initial, and let us say this is the y direction I am looking at. Okay. I need only one reference here. The reference could be the initial starting point of this. Okay. And therefore the y displacement, virtual displacement that has occurred is in the positive and upwards, delta E upwards. So, that is why 5 plus 5 times delta E. Here delta D is upwards, 10 is downwards. So, I have to have minus 10 times delta D, which is minus 10 delta D, okay, and this is equal to 0. Simple. Now, if I have to find out, if I find out delta E equals something times delta and delta D is equal to something else times delta, if I substitute over here, delta will separate out, I will get the equilibrium concerning AY phi 1 minus 10 and can solve it. Okay, it is as simple as that. We will come back to that after finding out the relationships between these. Okay. So, I am going to draw this again over there. Delta A, it is 1 time delta A. Okay, remember positive equal to, this is positive, this is positive. Now it is very simple, I just have to take this to be delta, this to be delta, and I get the answer immediately. So I have AY plus 5 minus 10 times delta equals 0 implies AY equals 5 kilonewton. All right. Now there is a doubt, let us see if we can clarify. Supposing I have a rigid body, let us say straight member like this, the only way that this displacement can occur is by movement like this. Okay, so this is the upward movement, mind you I am just using the upward movement here. This rotation is given counterclockwise, okay, that is the given virtual displacement, okay, in this particular case virtual rotation, okay. Consistent to this virtual displacement I need to find out, this is an upward displacement delta B, this is a downward displacement delta C, okay, and again consistent to this I should get this which is delta D, simple. Now once I find out delta B, from that I will find out delta C, from that I will find out delta D, okay. So what I am going to do now is find out kinematically admissible virtual displacements, because now we know we have to do that in order to provide the displacements, virtual displacements at 5 kilonewton and 10 kilonewton apart from the virtual rotation that is already given, alright. At E, the distance from that support A to E is 1 meter, right, and therefore delta E, is it upward? The answer is yes. The delta E is equal to 1 meter times theta A, upward, okay. What is delta B? Delta theta A, remember the direction of MA is counterclockwise, theta is also the rotation in counterclockwise direction. So this is a positive quantity, plus 5 kilonewtons times delta E, delta E is equal to theta A times 1. How about this? This is a positive delta D but a negative this thing, so it is minus 10 times what is delta D, it is 2 theta A, so it is 2 times theta A, and that is equal to vice versa. Supposing I need to find out kinematically admissible displacements from a set of equilibrium forces, it is possible to find out, okay. We will take up that example in the next module. Any questions? Is this clear? Now as an exercise I want you to apply both the virtual displacements vertical and rotational and then consider what is going to happen. I will give you a clue. The first thing that you have to do is at this point A, if this is stuff, this is B, this is C, what have I released? I have released the support completely. I will have AY and the moment MA acting on this. There will be this active force at the middle equal to 5 kilonewton, here 10 kilonewton. I have these supports still present. This is the body for which I need to find out. What should I apply? I should apply a vertical displacement and a rotation. If I do that, then I will be able to find out. So what will happen? I can apply vertical displacement and a rotation, which means I will be applying like this, mind you. Okay. So this is the rotation theta A, this is the displacement delta A, and find out consistent to this. So you know how to find out this, from which you will find out this, from which you will find out